Year 2050, humanity aims to achieve something truly remarkable. We are planning to build our first city on another planet. That planet is Mars. This isn't just a story from a science fiction book anymore. It is a real goal that scientists and engineers are working towards today. Imagine looking up at the night sky and knowing that people are living there, on that small red dot. This new home will be a testament to human ingenuity and our unyielding spirit of exploration. The first Martian city will start small, a collection of habitats and laboratories, but it will grow into a bustling outpost, a second home for humankind. Why Mars and not our closer neighbor the Moon? A base on the Moon would be easier to build and supply. It is only a few days away. But Mars offers something far more valuable, the potential for true self-sufficiency. Unlike the Moon, Mars has a thin atmosphere, frozen water, and a wealth of minerals in its soil. This means we can learn to live off the land, creating everything we need right there. A moon base would always be dependent on Earth, like a remote scientific station in Antarctica. A Mars city, however, could one day become a truly independent branch of human civilization, a backup for our species. The journey to Mars itself is a major reason why self-sufficiency is not just a goal, but a necessity. Getting there is a long and difficult voyage. A trip to Mars can take anywhere from 6 to 9 months, depending on the alignment of the planets. This long travel time makes sending supplies incredibly expensive and impractical. We can't just order a delivery from Earth if something breaks, or we run out of food. The launch window to travel efficiently between Earth and Mars only opens up every 26 months. This long delay means the first Martian settlers must be able to survive and thrive on their own for years at a time. Because of these challenges, the first inhabitants of Mars won't be human. They will be robots. Long before the first astronauts set foot on the red dust, fleets of autonomous machines will be our pioneers. These robots will be the construction crew, working tirelessly to prepare the ground for our arrival. They will mine for resources, print 3D structures, and assemble the first habitats. They will lay the power grids and check that life support systems are working perfectly. When the first humans finally arrive after their long journey, they will step out not onto a barren wasteland, but into a basic functioning outpost ready to become a home. To build a city, you need builders, and on Mars, our first builders will be advanced robots. These machines will be sent ahead of any human crew, tasked with the monumental job of initial construction. Think of them as tireless workers who don't need to breathe, eat, or sleep. They will be equipped with 3D printers that use Martian soil, or regolith, as their building material. They will excavate underground areas to protect future habitats from radiation. These robotic pioneers will also deploy and set up the first power systems, most likely vast arrays of solar panels to capture the faint Martian sunlight and store the energy for the long, cold nights. The most important task for these robots will be to locate and extract water. Water is the key to life, and on Mars, it is locked away as ice, mostly in the polar caps and buried underground. Robotic rovers will be sent on prospecting missions, using ground-penetrating radar to find the most accessible ice deposits. Once found, large drilling and heating machines will melt the ice and pump the resulting water into storage tanks. This water is not just for drinking, it is the single most critical resource for the entire colony, providing the foundation for everything else that will follow, from growing food to creating breathable air for the colonists. Another incredible piece of technology will allow us to make rocket fuel on Mars itself. This is a game changer. The process is called the Sabatier reaction. It uses Martian carbon dioxide, which makes up most of the planet's atmosphere, and combines it with hydrogen brought from Earth, or extracted from water ice. This reaction creates methane and oxygen, the two key components of a powerful rocket propellant. Having a Martian fuel station means we can refuel rockets for the return journey to Earth. It also means Mars can become a base for further exploration of the solar system, a stepping stone to the asteroid belt, and beyond. Building shelters on Mars will require clever use of local materials. We can't ship heavy building supplies from Earth. The first habitats might be inflatable structures brought from home, which are then buried under several meters of Martian soil. This soil provides excellent protection from the harsh solar radiation that bombards the planet's surface. Other ideas include building domes made from ice, which is surprisingly strong and translucent, letting in natural light. A more advanced method involves creating a material called biocrete. mixing Martian regolith with special bacteria and a binding agent to create a substance as strong as concrete, literally growing our buildings. Once the first human settlers arrive, their survival will depend on 5 essential things: water, air, energy, shelter, and food. The robots will have prepared the basics, but it will be up to the colonists to manage and expand these systems. Water, extracted from the Martian ice, will be rigorously filtered and recycled. Not a single drop will be wasted. This precious liquid will be used for drinking, hygiene, and for splitting into its component parts: hydrogen and oxygen. The hydrogen can be used for making rocket fuel, while the oxygen is the key to creating a breathable atmosphere inside the habitats. Creating breathable air is a constant, life-sustaining process. The oxygen obtained from splitting water molecules, a process called electrolysis, will be carefully mixed with nitrogen and other gases to mimic Earth's atmosphere. This manufactured air will be pumped into the sealed habitats where people live and work. Advanced life support systems will continuously monitor air quality, scrubbing out the carbon dioxide that humans exhale. This captured carbon dioxide is not a waste product. It will be fed back into the system, either to create more rocket fuel or to be used by plants in the colony's greenhouses. Every element is part of a closed-loop system. Powering a Martian city will be a significant challenge. Mars is further from the sun than Earth, so solar panels are less efficient. However, they will be the primary source of energy, spread over vast fields to collect as much sunlight as possible during the day. This energy will be stored in advanced batteries and fuel cells to provide power through the freezing Martian nights and during the planet's frequent dust storms, which can sometimes block out the sun for weeks. As the city grows, it may be possible to supplement solar power with small, safe nuclear reactors, providing a more reliable and constant energy supply for an expanding population. The greatest long-term challenge will be growing food. Martian soil, or regolith, is toxic to Earth plants. It contains compounds called perchlorates and lacks the organic nutrients that plants need to grow. Before any farming can begin, the soil must be processed. It will be washed to remove the harmful chemicals, and then mixed with nutrients and bacteria brought from Earth to create a living soil. All farming will take place inside pressurized greenhouses or vertical farms, with carefully controlled light, temperature, and humidity. The first crops will likely be fast-growing and hardy, like lettuce, radishes, and potatoes, providing fresh food and a vital psychological boost for the colonists. Establishing a self-sustaining city on Mars is about more than just adventure or scientific curiosity. It is a crucial step for the long-term survival of humanity. Our planet Earth is wonderful, but it is also vulnerable. Throughout history, life on Earth has faced extinction-level events, from asteroid impacts to supervolcanoes. By becoming a multi-planetary species, we give ourselves an insurance policy. A thriving, independent city on Mars means that if a catastrophe were to happen on Earth, human culture, knowledge, and our very existence would have a chance to continue. It secures our future among the stars. The process of learning to live on Mars will also drive incredible innovation back on Earth. The challenges are immense, and solving them will force us to develop revolutionary technologies. We will need to master closed-loop life support, perfect water recycling, generate clean energy in difficult conditions, and grow food with extreme efficiency. These technologies will have profound applications on our home planet. They can help us tackle problems like water scarcity, sustainable agriculture, and clean energy production, making life better for everyone on Earth. The quest for Mars is a catalyst for a better future right here. Of course, the journey will not be easy. The first Martians will face dangers and hardships we can barely imagine today. They will be living in a hostile environment, millions of miles from home, relying entirely on their technology and each other. They will be true pioneers, pushing the boundaries of what is possible. Their courage and resilience will inspire generations to come, just as the first explorers who crossed Earth's oceans did centuries ago. They will carry the hopes of all humanity on their shoulders, taking that one small step and turning it into a permanent foothold on a new world. In the end, building a city on Mars is the next logical chapter in the human story. We have always been explorers, driven by a deep-seated need to see what lies over the next horizon. From the plains of Africa, we spread across the globe, and now we are looking to the planets. Mars is not just a destination, it is a promise. It is the promise of a future where humanity is not confined to one world, but is a true citizen of the cosmos. By 2050, that promise could be our new reality, a red dawn for a new era of